Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7.3. And these are going to be when angles are formed outside of a circle. Okay. So what we're focusing on today is if a tangent and a secant, two tangents or two secants intersect outside a circle. Now let's talk real quick about what a secant is, because that's going to be a new term as well. Okay. So a secant is going to be a line that intersects a circle twice and exists inside and outside the circle. Okay. So this is just my basic secant like this. If I have a circle and I just draw a line that crosses twice, but like a kind of like a chord, but I extend the chord further. Okay. So it has to be outside the circle as well. So when we have the intersection well, we'll draw each of these out. But when we have these different intersections, the measure of the angle formed is half the difference of the measures of the intercepted arcs. Okay, so I'm going to draw my secant, and just make a little consistency here. Let's have the same circle each time, and one more. There we go. So when we have a secant, we have this secant here, comes together like that, and that comes with this secant here. So there's my secant. If I have a tangent, it's going to do something like this. Try to draw my best I can. And draw it right there. There we go. So there's two tangents, and then also a tangent secant. There we go. Here's my secant, and here's my tangent. Okay. So when I intersect with these, okay, remember tangents are only crossing one time. We get pretty much the same relationship every time. So here's my angles that are outside the circle. That's what's being formed here. Okay. So I call this angle 1, angle 2, and angle 3. So when I do this, I can do, let's go with A, B, C, D. I'll go with A. I think it's important to have one more point here, so we'll call it a point C, and then this will be B. And then we can do, we'll go A, B, and C here. So angle 1 is going to be 1/2 the arc AB minus CD. Okay, so when you look at that, here's my AB minus the CD. Okay, for the next one, I'm going to have angle 2 is going to equal to 1/2 arc ACB minus arc AB. And again, it is this arc minus this arc here. For the last one, angle 3 is going to be equal to 1/2 arc. It'll be AC minus BC. Okay, so here's this arc and then minus this arc. The pattern is the same every time. If I try to simplify that a little bit, I'm going to say this. Basically, the outside angle is equal to 1/2 the outer arc minus the inner arc. Okay, that's what I mean by that. So when I say outer arc, I mean this one here, this one here, this one here. And then the inner arcs are all in here. So that's the setup on all of these problems. They are all going to be subtraction problems with this. So we're just going to go over this one example, but then you can, and yeah, I'll set up these other ones just so you can have examples of that. So we have find the value of x here. X is my angle on the outside. So we have 170 is this arc and 72 is that arc. So that means the measure of angle x is equal to 1/2 of 170 minus 72. So now it's just simple subtraction and multiplication. We're going to have 1/2 of, that'll be 98. So the measure of angle x is going to equal to 49 degrees. All right. Now, there's a variety of things that can happen with this because we can make these into very different types of problems. So I'm just going to set these up so you can see that how it works. So for example, here, I'm given the angle. But I'm still going to follow the same pattern. That outer angle is equal to 1/2 the difference of the outer arc. So y in this case minus the inner arc. Okay, so now it's a matter of solving this out. Now, one thing I would do for my first step, I'm actually going to multiply by 2 over 1 to both sides. That way I get rid of my fraction there. So that's going to be 52 is equal to y minus 30. And I might as well just finish it up. And now I can add 30 to both sides, and I get 82 for y. Okay. This one is probably one of the more challenging ones. We got to be careful with this one. 30 is on the outside. I'm going to take 1/2 the difference between the two arcs. So here's my outer arc. Here's my inner arc right there. But when I do this, I need to be careful because I want to do 1/2 of, it'll be 5x plus 10 minus 3x plus 4. Okay. So the trick here is this part. When I subtract all of this, I am subtracting the entire arc. So it needs to look like this. It'll be 30 is equal to 1/2, be 5x plus 10 minus 3x minus 4. From here, everything else is going to be just algebra, like combine like terms here, combine those like terms, and you're going to work it through and solve for x. But the key here is this step right here. If you are subtracting the entire arc, it's going to be the opposite of both those items. So it's a negative 3x and a negative 4. Okay? And that's actually it for 7.3. In the entire part of 7.3 is just simplified to this idea. The angle that's formed on the outside of these different intersections is always 1/2 the difference of those two arcs, with the outer arc minus the inner arc. Or you could say like the bigger arc minus the smaller arc, if that makes more sense. But I like to think of it as this is on the outer part, like this is further away here, and then this is the inner one. It's closer to this point like that. Okay. And that's it for today. So take care, everyone.